smallest value, only we have to consider the Poisson's ratio value. Okay. After that, we have to calculate the stiffness matrix. Stiffness matrix, we are having the same formula, B transpose dB into A into D. Area value already we have to calculate it in our step 1, area of this CST element. T means the thickness value, thickness of the given CST element value will be given either 10 mm or 20 mm. Okay. After that, we have to calculate the element stresses. Element stresses at the x direction, y direction, which means sigma x and sigma y, and the shear stress which is denoted as tau xy. Okay. The formula is dB into displacement values. Displacement values along the x and y directions will be given in our problem. U1, U2, U3, and V1, V2, and V3. Okay. I already told sigma x and sigma y are the normal stresses. Tau xy means shear stresses, and U and V are the normal nodal displacements. Displacement along the x direction as well as the displacement along the y direction. After that, after calculating the normal stresses, based on that normal stresses, we have to calculate the maximum normal stresses and minimum normal stresses. Already you are studied in your strength of material. Okay. We are calculating this maximum and minimum normal stresses. We have to calculate the principal angle. We are principal angle which is denoted as theta p, which will be calculated which is equal to 2 tau xy divided by sigma x minus sigma y. We are solving this problem. We are getting the principal angle theta p. How much angle we are fixing our CST element? More than we are having the 28 to 29 degree. We are building our CST elements. Okay. After that, we have to calculate. In our previous steps, we are calculating the basic element stresses and normal stresses. After that, we are calculating the element strain. Element strain, we are having the different formula which is equal to E is equal to B into U. Already we are knowing the value of B, which is equal to B means strain displacement matrix. We are already calculated the B value. Okay. Then by using this B and U means normal nodal displacement U1, U2, and U3, and V1, V2, and V3. By multiply this, we will get the element strain value. Okay. Again, element strain value at the x direction, y direction, and normal shear strain. Okay. After that, if your questions we are asked the temperature effects, means we are using this formula like temperature effect alpha into delta T. Delta T means this is the temperature effect. How we are increasing the temperature from the starting stage to final stage. In our starting stage, they are giving the temperature like 30 degrees Celsius. After we are applying the load and all, it will be increased to 30 to 60. So automatically we have to calculate the temperature effect, which is equal to maximum temperature minus minimum temperature. Delta T is equal to so to 60 minus 30, we will get 30 degrees Celsius. Okay. After that, we are having the plane strain problem. Means we are using the Poisson's ratio, which is equal to 1 plus V into alpha. Alpha means the coefficient of CST element, coefficient or coefficient matrix value of the CST elements. Okay. After that, we are calculating the element temperature force, which is having the different formula. F is equal to B transpose D E naught into T into A. Again, B is the strain displacement matrix. Already we have to calculate it. And we can transfer the rho into column, means we are transferring the strain displacement matrix into B transpose. After that, we are calculating the stress strain relationship matrix, and E naught, which is denoted as the normal element strain, and T means thickness value, and area is equal to already we have to calculate it in terms of mm square. Okay. After we are solving all these things, finally we are calculating the basic things and all stiffness matrix scale and the normal stresses and the normal strain in the same function and the temperature effects. Okay, this is the basic introduction regarding our two-dimensional problems. Any doubt in this two-dimensional problems?
Yes.
No. Can you tell any difference between these two-dimensional problems and one-dimensional problem? Single line, we are having the two coordinate points. Here we are having the three coordinate points, which is denoted as node 1, 2, and 3. Joining these three nodes, we are having the CST elements. Any other difference? The basic difference is in our one-dimensional problem, we are only calculating the displacement value at only one direction. So only we are calculating the displacement value as u1, u2 and u3. Either the vertical direction or horizontal direction only we have to calculate the displacement values. In our two-dimensional problem, we can consider both the direction. Like we are calculating the x direction, which is denoted as u1, u2 and u3. In our y direction, it is denoted as the v1 and v2 and v3. This is the main difference between the one-dimensional and two-dimensional problems. Any other difference? You know the difference between plane stress and plane strain condition? Plane stress conditions, we can consider the normal stress and shear stress value, which is directly perpendicular to the axis, will be considered as 0. Again, plane strain means we can say normal strain and shear strain, which will be considered, which is equal to 0. Here the normal stress, here the normal strain, which will be considered, which is equal to 0. Okay. Any other doubts? Okay, next class we can discuss about the problems related to CST. Okay, thank you.